Sorry, I accidentally bounced you back too fast. I closed the breakout rooms on accident. My bad. I've done that a lot in differential equations. Sorry. Stuff accidentally closed sooner than I wanted it to. Thank you for being patient with me on Zoom as I figure stuff out. My bad. Sorry about that. Okay, so I heard a bunch of you. I didn't make it into breakout room number 4 because I accidentally closed them before I got there, but I heard you talking about non-trivial square roots. This is totally the process for finding a non-trivial square root of 1 mod n. That is absolutely positively the same process. Now, I didn't make it into breakout room number 4, but I did in 1, 2, and 3. Does anybody have a link between non-trivial square roots of n and prime versus composite? Did we find the link between those? Anybody, anything? Anybody, anything?
Primes have no non-trivial square roots of 1.
Mod the prime, right? So yes, primes have no non-trivial square roots of 1. In other words, if n is prime, there does not exist a non-trivial square root of 1 mod n. So that's your link to prime and composite. If you think that you do not have a non-trivial square root of 1 mod n, you output prime. The problem comes in with the value of a that you chose. And this goes back to what we did with the PowerPoint on March 4th. Here's your process. If you have the value before 1 not being -1, then you've found a non-trivial square root of 1. But remember that you picked a value, we called it T here, we called it A in the Miller-Rabin primality test at random. Sometimes that one doesn't work. So that's where this is coming from. Okay, questions on why the Miller-Rabin primality test works and why sometimes it doesn't? Anything there? Other questions in general about how you want to execute the Miller-Rabin primality test? Or other questions in general? Elijah, yeah.
So for choosing A, is there like a certain number of possible A's that you can choose, or does it's just any integer, any positive integer?
Any integer that's less than n, bigger than 1, and it depends on your confidence level, right? If you want to be super confident, you will try all of them, and that will guarantee that you get the correct output or prime of composite, but that's just stupid because then this makes this test slow and is not really helpful. So you can decide what your threshold is, how many values of A you want to try, and what is enough that will give you confidence that your output of prime is correct. Anything else? Other questions on the Miller-Rabin primality test? Do you feel comfortable executing the Miller-Rabin primality test? Because I think I have that on your homework. Yes, good, comfortable executing the Miller-Rabin primality test? Okay. On Friday, because today is Wednesday and I'm losing track of my days, on Friday, we are going to talk about a mathematical concept that we need in order to execute the last primality test. So Friday, we're going to talk about this new mathematical function, and then Monday, we're going to talk about the Solovay-Strawson primality test. That's the last one that we want to hit. I'll probably also come up with just a quick list of other primality tests that exist that we don't want to use. So I think I'm good. Any other last minute questions before I let you guys go for today? All right, super. Okay, I will see you Friday. Thank you for signing in and have a lovely day. Bye, guys.
Bye.